Hello, everyone, and welcome to our webinar on Cisco IOS XE programmability and automation. We're going to talk about pandas, not necessarily the cute bears, but the programmability and automation white paper that the Cisco IOS XE TME team has put out a while back. So my name is Adrian Liasiu. I'm a developer advocate with Cisco Developer Relations. I cover enterprise networking, and one of the technologies that I do cover there is IOS XE. So today, together with Jeremy Coho and Story DeWeese, we're going to go ahead and show you a bunch of demos, use cases. We're going to talk about Cisco IOS XE programmability and automation, like I was saying. If you have any questions, drop them in the questions window. I will be monitoring the questions, answering as many as I can. And if there's any important ones, we'll bring them over and we'll have Story and Jeremy address them too. So let's get this thing started. Story, you want to get going?
Yes, thanks, Adrian. Okay, so I'll start off by sharing our agenda for today. So we'll talk about the white paper that we've recently published and share details about how to actually access this white paper. And we'll discuss an overview of programmability and automation, or P&A, or as we like to call it, Panda. And today we'll go over various demos throughout the programmability and automation lifecycle. So that includes day 0 of device onboarding and day 1, where we're actually configuring and making changes to our devices. And then we'll move on to day 2, where we're looking at telemetry and metrics from our devices themselves. So we have a lot of links and resources throughout this session, and we'll be going through these demos with you live. And all of this is included in our white paper, so you have the text version of that to look at afterwards as well. And I encourage you to definitely ask questions and be engaged in this session, because we're happy to answer anything that you may have that may come up throughout the session today. So with that, I'll pass it over to Jeremy to get us started.
Hey, thanks, Story. So here we're talking about programmability, device programmability, direct to your Cat9K devices, your ISRs, your ASRs, your C8Ks. But we have a whole nother set of software controllers that we're able to use programmable use cases against and instrument against. But today we're talking directly to the device. Right, that's like kind of the bottom part of this slide, which is in the campus and for IOS XE. So we're talking about IOS XE 17, and a lot of the new features that we're going to be talking about, you'll be seeing that as we've covered them in the white paper. But as we see from this slide here, we do have a controller first strategy. So a lot of the use cases that we're talking about today can be solved by these software-based controllers, by the Cisco DNA Center, by Nexus Dashboard, by the CrossWorks Gateway, or Edge Suite over there. So we have a couple options when we're using controllers, but when those don't always fit our needs, then we need to go to the device, directly to the device. And that's what we'll see in the next slide here. All right, so specifically when we have like unsupported use cases, when we don't have a DNA center, or when we have an edge use case. So for example, when we want to collect a specific counter or KPI, or we want to collect that over an extremely long period of time, or at an extremely aggressive interval, so maybe 1, 2, or 5 seconds, where we want to look at some specific counter. This is what we're going to be talking about throughout the white paper, and this is what's really enabled on our platforms. So this is what we'll see in the next slide, is that kind of on the left here, we have our Cisco solutions, right? The Cisco DNA centers, the Nexus dashboards, the software-based controllers. But where we're going to focus today is on kind of the right half of this, which is the third-party integrations and the do-it-yourself solutions. Right, so there's a lot of off-the-shelf, commercial off-the-shelf, and open-source projects that you'll see us mentioning here. Some that come to mind are like Jenkins and Puppet and Ansible, but we also have a lot of integrations for the do-it-yourself solutions. And you'll see us specifically talking about Yang Suite, and that's the tooling that we have that integrates with the APIs and enables us to do testing and validation for a lot of these features. All right, so we'll get into Yang Suite and all these features in detail in the next little bit. So let me pass it over back to you, Story, to talk about how we can actually find some of this information that we're going to be going through next.
All right, awesome. Thanks so much, Jeremy. So to get started, as you know, throughout the session, we'll be talking about our API white paper that's recently been published, recently been released. So you'll see there are a couple of QR codes where you can actually go and access our white paper. So it's free, publicly available to you. And we also have the links down at the bottom. So you can access this from the website, or if you prefer a PDF version, we have that as well for you. So that's what these two QR codes, two links are for. So over on the left side of our screen, we're showing all the different content that's within the white paper. So we'll be covering all the days of the programmability and automation lifecycle, as mentioned, starting with day 0 of device onboarding, and then moving into device configuration and looking at device monitoring, then moving to device optimization in day N. So we'll actually be showing use cases and examples throughout each of these days during this session. And we just want to give you a taste of what some of this can look like. So looking at some actual examples, so it's a little bit more tangible for you. But again, all of this content is listed in the white paper itself. So you'll have code examples and resources to refer back to after the session. So as a quick link, we have a blog about this white paper. So again, this QR code leads to the link to the blog itself. And from there, you can quickly and easily access the white paper, see some of the benefits of it as well. So now let's get started. We have been talking a little bit about the programmability and automation overview or lifecycle, and we'll be going through these different days today. So first, I'll start off with day 0, which is device onboarding. So you can see this here in the top left corner. And we can go ahead and get started with this one. So as Jeremy mentioned, when we talk about device onboarding, sometimes we talk about DNA Center, or this is one of the controllers that we have available to us. So if you worked with DNA Center, you may be familiar with plug and play. And that's what's shown over on the right side of the screen. Now, on the left is actually what we'll be talking about today, which is zero-touch provisioning for a controller-less setup. So we don't have a controller. This is completely do-it-yourself. And we'll be using Python files to actually go in and configure our device for the day 0 setup. So this is an overview of what we'll be going through today. So with ZTP, we actually are going to use two different things. First, we're going to use gNMI reset. So we'll be resetting our device back to its factory settings, and we'll be using this key flag of zero fill. So that means that we'll be going through and wiping out any data that may currently be on our device and completely resetting it back to its factory settings or initial state. So we can go ahead and take a look at this together. Yes, hopefully you can see my screen here. So I just ran this command, the gNMI reset, and we can see that the reset was successfully called. So over here, our device should be going through the reset process, and we shouldn't be able to access it just yet. Right, so we're seeing that the device is unreachable, and that's because it's currently going through this reset process. We're going to bring it down and then bring it back up. So while it's going through that process, we can actually take a look at some of the day 0 config. So how are we working with zero-touch provisioning? So we'll look first at the DHCP config itself. And let's actually look at the file.
Oh, so yeah, there we go. You found it.
Yes, thank you. So here we're actually configuring the option 67, and this is needed to actually use a zero-touch provisioning here. So what we're doing with this option is we're defining, okay, this is the boot file that we're going to be going to actually reset our device. So here, this is on the virtual machine that we're currently running in this window. And we'll be looking at this ZTP simple.py file. So essentially the point here is we've enabled option 67 within our DHCP config, and we've defined which Python file or scripting we want to use to go out and configure our device. So the next step is to actually look at this. What is this file that we're going to be running whenever we do, our device comes back online and we're able to actually start configuring it. So here at the very top, we can see that we're importing CLI, and we'll be using this library, this module throughout the file in a few different ways. So the first thing we're doing is based on the device itself, we're going to give it a host name, and then we go ahead and configure the host name on our device. So looking at a few other examples of using CLI configure, we're actually configuring VLANs here. So you can see we're configuring VLAN 1, and we're also configuring some IP addresses and all of this good stuff here. So if there's anything that's needed in the day 0 config, that can all be done directly through a Python file such as this one, where we're using the CLI configure P. And so as you can see, we just had a change here. So first it was unreachable, and now we're seeing that our device has come back online. So we should be able to see, yes, our device is accessible now, and it's just gone through this process here. And we can see that it's actually up. So we've gone through and configured our hostname as expected. And so we went through this whole process where we used the gNMI reset, and then we went through ZTP to go out and configure our device. And now you can see it's no longer in the factory reset state. Now we've actually configured it for our day 0 needs. So that concludes this first demo that we have for day 0. And again, we have examples in the slides if you'd like to refer back to those later. So next we can talk about Yang Suite, and this we'll be using for day 1. So within Yang Suite, we can do a lot of different things. It's a Yang API testing and validation environment. So this works for Cisco IOS XE, XR, and NX systems. So we can do a lot of different things, but today we'll be sort of zeroing in on this Ansible integrations portion. So let's move over to Yang Suite. Okay, here we are within Yang Suite now. And
hey, sorry to interrupt here just before we continue into the Yang Suite demo. Just on the bottom of your screen, there's like a hide button. Can you click that? And then we can, yeah, awesome. Now we can see the whole browser window. Thank you.
Okay, thanks, Jeremy. Yeah, just continuing on here. So we have Yang Suite, and here I've gone ahead and selected the Yang set for my device. So I've done all of the initial onboarding for Yang Suite and the setup initially. And I've gone ahead and loaded the interfaces module. So we also have a Cisco IOS XE native here. So we've loaded these modules, and we can go ahead and decide if we want to either git config or edit config from our device. So today we'll choose to edit. We want to make a change, and we've selected our 9300 that we'll be configuring today. So let me just make sure this is loaded.
Might just have to refresh the page.
Okay, let's try this here. Okay, need to log back in.
Yeah, session timed out.
Okay, so now for our interfaces, say I want to change the interface description. So I'll pick an interface here, and I want to say that it's configured by Ansible. So the typical workflow for Yang Suite is we'll use our Yang models here and select the different changes that we want to make. Then we go through and build up our RPC. So here you can see that all of this is created within XML. And typically we would go ahead and run this directly to go on and configure our device. But in this case, we actually want to use the replays feature. So here, we'll look at the replays, and we can either generate a Python script or an Ansible playbook. So for the purposes of this demo, I'll go ahead and use the Ansible one. So here, I'll say we want to configure like an interface, and we can define the playbook name And we can also go ahead and add a task name too. So task int, and I'm just using these as examples here. So we can go ahead and download our playbook and open it automatically. And here you see a lot of comments up here in green, and this is telling us exactly how we can actually use this file and how we can run this playbook. One thing that you'll note is we're using NETCONF here, and this payload is the same one that we had generated back in Yang Suite. Now we can use it in this Ansible file as well. So that concludes our day 1 demo of how we can use Yang Suite tooling and Ansible playbooks. And again, here's the demo to go through, but we did this one live. So next I'd like to talk about another tooling, which is Terraform and the Terraform provider. So you'll notice that we first released Terraform back in March of last year, so it's about a little over a year old. And we have two different, lost the lights here. We have two different providers that we've released since then. So one is for app hosting and one is for BGP EVPN. And these are declarative providers that have been built against the same SDK that we used for our initial imperative provider back in phase 1. So taking a step back, Terraform itself is a cloud-native infrastructure as code tooling. So it works really well with anything that you may be needing to do in the cloud itself. And we can move on to an example of what that will actually look like. So for Terraform, this is a use case where we're using crypto IPsec. So we're configuring things both in the cloud and also a tunnel directly on, say, a 9300X platform that will then give us as the user connectivity both to the cloud and to the switch itself through this secure tunnel. So again, we can configure things on our iOS XE device with this new Terraform provider, as well as things in the cloud, all using the Terraform tooling. And we also have a demo here that actually goes through this process. So for the purposes of time, we want to move on to the next demos. I'll hand it over to Jeremy next to talk about model-driven telemetry and how we can use this with some use cases and examples.
Okay, awesome. Thank you for that. I'm going to share my entire screen actually over here as we go through slides and demo for a little bit. So let me just move this one over as so, and let me go back to the PowerPoint slides, and here we go. Okay, so picking up where we left off with telemetry. So if we actually go back to the iOS XE Programmability and Automation overview slide, this is kind of like the device lifecycle, right, where we have the various days as we discussed just briefly in the intro. So we're talking about day 2, the device monitoring, which is the bottom right side of this in green. We'll touch on each of these points here, the TIG MDT container and examples. So this is the software stack that we're going to use and talk about to receive the telemetry as well as to visualize it. And we'll also take a look at some of the data models for on-change support, so we can actually understand how we can get event notifications sent to us when they actually occur. For this telemetry use case, we're using gRPC dial out. We're not using DNS, we're not using TLS or MTLS. We're just using clear text, like really basic stuff. But you can always layer those features and those knobs on top of the gRPC, the plain text telemetry. So that's kind of what we're going to be talking about, or having a demo of, which is going to look like this. This is our iOS XE model-driven telemetry kind of overview or day 2 demo that we're going to be diving into here shortly. So at the very top, we have the Cat9K devices. We have all, the family of switches up here. But as we mentioned, this could also be the ISR and the ASR or the iOS XE based routing hardware platforms, as well as the Catalyst 9800 wireless LAN controller product family. These are all running iOS XE, so these all have the same API and telemetry stack. In this case, we can enable this telemetry with CLI or using the API, using the Yang-based APIs. And then the tooling that we actually use to do that is going to be something like PyTS or Ansible, as we saw earlier. We also have tools like NSO, the Network Services Orchestrator from Cisco, as well as Terraform, as Story was talking about earlier, where we're developing a module or a provider to manage the gRPC model-driven telemetry feature using Terraform. Right, so this is how you can enable this feature, turn it on, and we'll take a look at the example on the switch coming up shortly of what this CLI looks like. So once we actually enable the CLI, then we get kind of to the bottom kind of left side of the slide, which is the Telegraph, the InfluxDB, and the Grafana. Right, and that's where it's collected, that's where the data is stored, and that's where we use to visualize it. And that's an example of that visualization is on the right side here, where we see some charts and graphs. We see some information about the fans and the fan speed and the RPMs and all sorts of metrics about the interfaces. Right, so let's get into the actual demo here. We'll get over to the actual switch. We'll take a look at the running config. Right, we'll get into the container in step 2 here, and we'll review the actual Telegraph configuration file that tells us how we're receiving the data and where we're going to save it to. We'll then go into the simple telemetry dashboard where we can actually see that data that we're sending from the switch in step 1. And this is then we'll move into step 4, which is the sustainability dashboard, which is showing us a more fully featured dashboard. Right, there's a lot more data on there. There's a lot more intelligence that you can glean from the sustainability dashboard that we'll demonstrate in step 4. So with that, let's get into the console here. So I'm just going to move the terminal window over here. You can see I was following along with Story here in the ZTP demo. So what we're going to do here is get into the switch. So I've logged into the switch here, and we can do a show run and take a look at the telemetry section. Right, it's pretty small. We just have one line of config here that basically tells us that the data that we're sending is this 5-second CPU counter metric. So it's essentially like us, typing, show CPU every 5 seconds, right? Except in this case, we're externalizing this data every 30,000 centiseconds. So what does that mean? Every 300 seconds, right? What does that mean? Okay, it's every 5 minutes, right? So every 5 minutes, we're sending, a snapshot of what the CPU utilization is like, right? Averaged over the last 5 seconds. All right, so we're sending this data out over to our receiver that's over here on the network. This 10113, that's where our Ubuntu VM, our collector, is sitting at. And this application is listening on this TCP port 57500. Right, so we'll see this port listed in the Telegraph configuration. If we do a packet capture or a TCP dump, for example, then we'll see stuff coming in on this once every 5 minutes. Okay, so let's get out of the switch. Actually, maybe we'll just do some validation before we leave the switch, just to make sure that the telemetry is connected. So we can just run some show commands. It's show telemetry, IETF, subscription, the subscription number, and then you got a couple options here. Right, if we just give it nothing, right, it's going to tell us that it's valid, it's configured, and the first level of checks are looking good. If we look at the detail for this, then we'll see essentially what we're seeing in the configuration, which is that we're sending the 5-second CPU stuff every 300 seconds. Here we actually get some details about the receiver, right? So we understand that we're in a connected state. It's been connected since, whenever we turned this on a couple hours ago, and it's connected to this host at this port. Right, so that's looking good. We can get out of here, and let's go into the actual Docker container where this data is being collected. So we can see from the show that we're sending the data on port 57500, and you can see from my Docker PS that I've exposed port 57500 into my container, right, into this telemetry container. So when we get into this container, we'll see data from the switch inside the container. Right, so I'm going to hop into the container, And if we take a look at the processes that are running, we can see that there's one here for Telegraph gRPC. All right, so this is the one that's going to be listening on this 57500 port per this config file right here. So if we go read out this config file, if we cat it out, we see here that the service address, we're listening on, all interfaces on this 57500 port. And this is on the input. What we're going to do is take a look at the outputs here to understand that we're sending this data to influx, like we saw on the slide. And we're also sending this data out just to a text file, right, in the temporary folder. So we can just tail out this file, and we should see a bunch of telemetry coming in. Let me just make it a little bit smaller. It might be a little bit harder to see now, but you can kind of understand that every 5 minutes we're getting one log message from our pod 17 switch, and it's telling us that it has this 5-second CPU metric in it. It's integer, which is sitting at 0, right? My switch is sitting here doing nothing, right? There's not much going on, so the CPU is at 0. So when we move over to the visualization engine, then we'll see, or we should expect to see, pretty much a flat line, right? Telling us that the CPU is at 0 or has been at 0 for at least the last half hour or so. So with that, let's move over into the Chrome window here. And here I am looking at this general device monitoring dashboard. We can edit up this dashboard and we can understand what we're looking at, that we're using this database from Influx, we're querying the CPU utilization, and we're looking at the 5-second counter that we saw coming in. Now we're also querying the 1 minute and the 5 minute, but we're not actually sending that data. As we saw from the switch, we're only sending just the 5-second data. So part of the lab, or part of the use case here, is to go and enable these other 2 telemetry counters and then start seeing that data in here in a much more aggressive interval. So this is the data in Grafana. If we go back to look at kind of a wider time frame, maybe like the past 6 hours, we can see that the thing's just been sitting here pretty much doing nothing. And I don't know how much data we have in here. If we just back this thing out to maybe 7 days. Okay, so here we have 7 days worth of data, right? We can see, the CPU's been sitting here at 0, all the time, except for sometime around here. When was this? Right, sometime around April 8th, or 2 o'clock in the morning, the CPU spiked up to 1%. Okay, so it's not really a spike, but there was an increase, and we did actually get to capture that in the telemetry. And that's kind of the point of this, is that you don't have to sit here doing show CPU every 5 seconds for a week. But when you are looking for that spike, and if you do need to correlate this, well, now we easily can. So this is the telemetry. The simple dashboard looking at the CPU.
So, right. Jeremy, before we move forward, there was a question coming in from Dimitrios. So he's asking, what would be a secure way to stream the gRPC data over the internet in a VPN-less connection? Is it MTLS? Is there a best practice?
That's a great question. So it's about how to secure the telemetry over the WAN. Right, and we have customers doing this in production. We have large service provider type customers doing this in production over their WAN from their various sites to their various cloud data centers. And you're exactly right, Adrian, where the solution is to use a combination of TLS to encrypt the data, and coupled with mutual TLS or MTLS to secure the connection to the server. Right. In this case, the server runs in public cloud. There's no firewall in front of it, or there's no ACL, but it's protected with MTLS certificates. So we'll only have a conversation if it's presented with a matching certificate. So this is how our customers are able to securely collect telemetry in production. And one thing that we didn't talk about was the DNS-based telemetry collection. So in the example here, we're using an IP address, 10.1.1.3. But we can use a DNS name. And then when we use a DNS name, we can, of course, benefit from DNS-based load balancing and geography-based DNS resolution, so that we can find servers or clouds that are closer to us rather than traveling longer distances. So we're actually going to be doing a case study about secure telemetry. I think it's at scale and in production, I think is what we're calling it. So you'll actually see some collateral, some white papers, and some other marketing stuff from us coming out in the next couple of months as we get a little bit more prescriptive about how we advise you to run this securely and in production.
Perfect. Thank you.
Okay, so we did 1, 2, and 3 on here. We looked at the show run, we looked at the telegraph and the config and all the stuff in the container, and then we just looked at the dashboard right now. So let's go look at kind of a little bit better dashboard, one that has a little bit more data than just kind of one counter that's not really updated very often. And that's going to be this one here, which is the POE for smart buildings dashboard here. And we've got a couple different things on this screen. On the top left here, we have the total POE and system power allocated. So what's happening here is that in the daytimes, we're seeing about like 700 watts of utilization. And then in the evenings, when we have some devices disabled or less use in the smart building, that we have the power draw reduced to around 250, 270 watts. And the way that we're able to get this savings is at a per port level. So what we're doing here is we're looking at individual ports, and we're understanding how much power that each of these ports are drawing from POE. So we have some ports up here that are drawing a pretty high amount of power, 74.3 watts. Right, this is like a smart light bulb, something like this, that's providing light to a general area in a floor in a smart building or in an office somewhere. We also have some other devices down here that are drawing less power. And we can actually see the same thing that, these are powered up until about 9 o'clock at night. And then they're disabled until the morning when the building reopens or when someone returns to the building, which is around 6 o'clock or 5:45 in the morning. We're able to see some detailed information in this table here about the power draw from these individual devices, right? So they don't actually report like CDP or LLDP device details or device name, other than a generic IEEE PD. It's a power drawing IEEE device. Sometimes with the access points or other CDP devices, you actually see the name, as we can see here. We actually have a 3560 switch drawing some power. We have some Catalyst 9120 series access points that are drawing 9 watts or 15 watts depending on the use. So within this dashboard, we can get pretty detailed information about the devices and how much power they're drawing, as well as how much power they're drawing over time. Right? We can select an individual one and understand, that something happened here where it was operating normally around 35 watts, and then it got cranked up to 70. Right? It got turned on to high power, or we turned the brightness up to maximum. And then it went back, on the next day back to its regular kind of, medium power, operating around 60 watts. Right. One nice thing about this is we can also just zoom in, and we can get even more detailed understanding about exactly when this changed. Right. We can see that it actually went down for a bit and up and down before it actually leveled out. Right. So this goes into our power calculations and the stability of the device, and really just helps us understand how these things that are plugged into the network are using the packets and using power. So with that, I think maybe let me pass it. Actually, is it me to close it up here with the rest of the slides? I think it might be.
Yeah, if you could wrap us up, Jeremy.
Awesome. Okay, thank you. So we just seen a bunch of demos, right? We saw the demos in day 0 for zero-touch provisioning, right? We saw the reset.proto, and we saw ZTP come up and automatically configure the device. Right, that's pretty neat, especially when we're deploying hundreds or thousands of these things. And we have examples in the white paper. We have some links that point you to GitHub repositories where we have very similar or very close to customary examples of ZTP, where you can actually you can see that we're deploying many devices programmatically using the solution in the Python script, the highly flexible Python script that was provided. For day 1, we saw Yang Suite, we saw the Ansible integration there, so that we can just run the Ansible playbook and configure lots of devices as we need to. For day 2 telemetry, we looked at the power over Ethernet, the smart building sustainability, as well as the telemetry container. As far as day N goes, we saw a little bit of that actually in the gNMI reset.proto in the very beginning. And then of course, ZTP is very tightly coupled with all the day N features, the guest shell, and the Python 3 API, right? And that's really what makes ZTP or enables ZTP to function the way that it does. Right, so lots of different things that are possible when you go direct to device. And oh, there we go. We do have some Teams rooms, right? So if you want to stay in touch with us, if you want to ask some specific questions about some of the toolings that we're supporting, we listed those on here for Yang Suite and for Terraform. And then our kind of reference when we get a lot of questions is this is the first place that we go to, which is the Programmability Configuration Guide. Right? We have the link here for 1710, which is the latest shipping or latest available programmability guide. And you'll see that we have day 0 covered in here with provisioning. We have our programmability in day 1. We have our model-driven telemetry, which is the day 2. And then pretty much everything else is the day N. So it's covered in here in quite detail. We spend quite a bit of time working with the various engineering teams and the documentation teams to make sure that this thing is accurate. Anytime we find any errors or typos or anything wrong in there, we're pretty quick to jump on it to get this thing to be the best that it can be, so that you can, when you're working with these features, you can more easily refer to this guide and find the solutions that you need right in there. Right, as I mentioned, we do have some GitHub links on here. This is actually in Code Exchange, in Cisco DevNet's Code Exchange platform. The ZTP examples, you'll see all those. Same thing with the Postman collections. We didn't really talk too much about Postman collections today, but we do have a bunch for programmability, for managing device features, for managing fabrics, all sorts of things that we've provided just to make it easier for when you're using the Postman tool to manage API. And then same thing with MDT. We have a pretty extensive lab guide that we contribute to Code Exchange that walks you through pretty much everything that we went through today in the Docker container, as far as reviewing the telemetry and building up the dashboards. And all of that's covered in this Code Exchange link for day 2 MDT. And then, of course, we link to that and reference that quite a bit within the white paper. So let's just wrap it up here. We've seen a bunch of demos, right? We've provided a bunch of links, primarily about how to go and find the white paper. Shared some resources for once you're working with the white paper to actually go in and turn some of these features and solutions on. And with that, let me say thank you. Thanks for your time. Thank you for attending. Thanks for your attention, and please engage with us. And with that, Adrian, let me just pass it back to you for any final words.
Thanks, Jeremy. Thanks, Jeremy and Story, so much. This was a really great session. So thank you all for joining our webinar, right? If there's any other questions, a bit of a last chance here to bring it in front of Jeremy and Story. If not, if you have any other questions following the webinar, you've seen the WebEx team spaces that we have links for in there. So make sure you join those spaces and ask us the questions in there. We're also, on developer.cisco.com. We have learning labs around iOS XE. We have sandboxes, and you will see in the sandboxes actually a bit of consolidation between the different sandboxes that we had around iOS XE. So we're also moving from CSR 1000V to CAT 8000V.
Yep.
So that's exciting. So be on the lookout for those sandboxes. They're coming out within, I'd say, the next couple of weeks. We're in the final stages of testing them. So if there aren't any other questions, then we'll wrap it up. Again, big thanks, Jeremy and Story, for showing us all these cool demos around Cisco IOS XE. And you folks be on the lookout. There'll be more webinars coming up in the near future around programmability and automation. So thanks, everyone, and see you on the next one.
Yes. Thank you.
Thanks, bye.